Hi, my name's Hugh from SRI, and today we'd like to talk about manual integration of the chromatogram. So I have on the screen a typical chromatogram. There's a big solvent peak here at the beginning, and then there's some smaller peaks here along the axis. This one's about at 7 minutes, something like that. So in Peak Simple, which is the name of our software, there's the black line. The black line is the data line, right? The peaks are the black line. And then there's the blue line. The blue line is the baseline. The baseline is a fuzzy logic algorithm that tries to figure out where the bottom of the peak is. In the old days, before computers were widely available, you had to print this chromatogram and then take a pair of scissors and cut the peaks out with the scissors and then weigh each peak to find out the size of the peak. A lot of people cheated and just assumed they were triangles, but if you needed high accuracy, you really had to cut the peak out and weigh it. But now the computer can do that, but in order to do that, it has to figure out where the bottom of the peak is. And that would seem like a simple thing, but oftentimes it's not. So we've built into Peak Simple a number of tools that the operator can use to override or help the integration algorithm figure out where the true bottom of the peak is. One of the rules that the blue line has to follow is that it can never penetrate through the black line, right? So if the signal goes down, the blue line has to follow it down and then again figure out where to start establishing its new position relative to the data. So here's a good example. Here's a big solvent peak. I'll zoom out a little bit so you can kind of see that the peak is a giant peak that actually went off scale. And then there's peaks that we want to measure that are on the tail of the solvent peak. Now, ideally, these peaks would be separated from the solvent peak, but in the real world, a lot of times the peak that you want to measure is on the tail of the big solvent peak. So the question is, how do you get the blue line to accurately figure out where the bottom of that peak is? So for instance, this peak here that's on the tail of the solvent peak, you can see that the blue line was nowhere near the bottom of this peak. So all this area under this peak is erroneously being added to the true area of the peak. So to fix that, we have manual integration tools and then we have automatic integration tools, and you can manipulate both. So to do that, you click on Edit and then Manual Integration, and then you get a toolbar, right? You can move the toolbar around or you can park it back where it was, but the tools, each tool, if you hover your mouse, explains what the tool does. So for instance, this tool here that I'm picking looks like it drops the blue line between the valley between two peaks, right? So if I pick that tool and then I click just before this peak, you see what it did. It forced the blue line to attach itself wherever I clicked, and at that point the algorithm said, oh, okay, now I'm oriented, now I can figure out where the bottom of these various other peaks are. But there are other situations, like this particular set of peaks here, right? These two peaks here. I'm going to zoom in by dragging a box around that area so that we can see it in more detail. And here the blue line has decided to connect itself to the valley between those two peaks. Well, that may be a good thing or it may not be a good thing, but if you don't like it, then you can pick this tool here, which shows the blue line being dropped from a valley down to a baseline below. So when I pick that tool and then click on that valley, you can see how it changed the way the baseline was drawn, and quite a bit more area would be added to each of those peaks as a result. So that would make a big difference in the answer. Here's another case here where there's a little peak. It's not really on the tail of the bigger peak, but it's close enough that the fuzzy logic algorithm decided to draw the blue line to the valley between those peaks. So if I pick that same tool and drop the vertical, then it integrates like that. Well, even that really isn't optimum, because really what's probably happening is this big peak is gradually coming down and this little peak is kind of riding on the tail of that. So that we have another tool that is the tailing tool, and I pick that and it draws the blue line like that, which is probably a more accurate representation. But you notice that the little red dot, the little red circle on top of the peak disappeared, because now this peak is so small that it didn't meet the area test. So to fix that, we go to Edit, Channels, and then Integration. and then there's a number here called area reject, right? So right now it's set to 10 area counts. I'm going to make it 1 area count, and then look, magically now that little peak has a red circle on there, so now that peak is being integrated, whereas previously it was being ignored. There's another tool that's very useful sometimes, and that's what we call the rubber band tool. So I'll pick the rubber band tool, and then I'm going to hold my left-hand mouse button down here, and wherever I drag my mouse, I get a blue line that follows the mouse. So wherever I let it go, that's where it draws the blue line. So with all these tools, you can fix pretty much any integration problem, but it's tedious to do this manually. So if we go to the event table, which is Edit, Channels, Events, and then click Add, there's a variety of events in the event table. There's mechanical events here like auto zero, and then the relays that close little contacts that turn on valves and things. And then in this middle column we have all the integration tools. And notice that they're in the same order that they are in the manual integration toolbar, right? So this first one is called integration none, and this second one is called integration dropped, and so forth. All these tools are replicated in this event table, so that if, for instance, you decide that you want the rubber band to start at 3 minutes and continue to 4 minutes, you can put an event in here, for instance, that says at 3 minutes, rubber band start. And then we'd add another event that said at 4 minutes, rubber band stop. Right? So when we go back to the actual chromatogram, here's 3 minutes right here where I'm pointing, and then 4 minutes would be here. Maybe it didn't do a very good example because it said it doesn't make sense. You don't want a rubber band that has to bend. The rubber band has to be straight. Let's pick a new place for the rubber band. I'll pick this time here 4.75 minutes to 6.04 minutes. So I'll go back to my event table and change this to 4.75, and then I'll change the next one to 6. Okay, so let's see if that does what we want. So when I click OK, it did what I wanted to. It started here at 4 minutes, and it dragged the rubber band over to 6 minutes, and you can see what it did. It has to be a straight line, though. It can't bend down. The rubber band can't bend down, so the integration algorithm wouldn't let me do it the way I wanted to the first time. So here I'll draw the rubber band. I'll use the rubber band tool manually now again, and I'll draw my rubber band from here to there, and you can see the effect. So you can play around with these features any way you like, but the bottom line is once you figure out what needs to be done, you go to the event table and then you set it up so that it happens that way every time automatically without your having to do anything. Okay, well that's a good introduction to the manual integration tool, so thank you very much.